This is a lesson over u-substitution, which is an integration technique used in calculus. So our first problem will be the integral of 2x cosine 2x. Actually, let's make that x squared. Sorry. And then dx. Now in u-substitution, typically your first step is to find the u. And to do that, you want to look for any inner functions. Now an inner function typically consists of any parentheses, square roots, or powers. And in this case, we are given the parentheses x squared. So that'll be our u. We then find our du, which is a derivative of x squared, which is 2x dx. And then we want to solve for dx to make this entire thing in terms of u, because so far it's in terms of x. So to do that, all you do is divide both sides by 2x. You notice that this one cancels out, and we're left with dx equals du over 2x. Great. So now if I move that over here so you see what we substitute, 2x, well, the integral of 2x cosine u, and then du over 2x. We substituted this value and this value. You then notice that these two x's cancel out. So now we're left with the integral of cosine u du. We then know that the integral of cosine is sine of u plus c. And it looks like we're done, but we're not. We still need to do something with this u, which is just to substitute it, again, with x squared. So now we have sine x squared plus c. And we're done. Now our next problem will be a definite integral. So let's do it from 0 to pi over 2. And let's do sine of x e to cosine x dx. And yeah, over here it looks a little complicated, but just use your inner function rule, which is anything inside parentheses, right? Square roots or powers. So in this case, it's powers. Because over here we have a cosine x, e to the cosine x. So that'll be our u. We know that the derivative of cosine is negative sine. And multiply it, or not multiply it, technically, to dx. And solve for dx, which becomes du over negative sine x. I'll move that under the u. And before you continue with this, remember when it comes to definite integrals, since we are putting this all in terms of u, right, you have to plug in your bounds into this x right here. Okay? So in this case, we're given pi over 2, which cosine pi over 2, because we are plugging it into our u, right, is 0. And then cosine of 0 is 1. So now our bounds is 1 to 0. It used to be 0 to 2 pi. So now we will plug in our sine of x, e to the cosine x, dx. Nice. And then now we will plug in, oh, I'm sorry, I didn't even plug in anything. So this is actually e to the u, and then our dx is du over negative sine x. And you see that these cancel out except for that little negative sign, so that becomes a negative 1 outside the integrand because it's a constant. And it becomes from 1 to 0, negative 1 times from 1 to 0, e to the u du. And from here it's pretty straightforward. We know that the integral of e to the anything, or not e to the anything, e to the x is e to the x. So in this case, e to the u would be e to the u. So negative 1 e to the u du, right? Or not du, sorry. Put it into the bounds of 1 to 0. And now we are just left with negative e to the 0 minus e to the 1, right? And eventually this equates to e minus 1. So hopefully my mistakes didn't confuse you. Let's head on to our next problem. And so this next one will be pretty easy. We'll just do the integral of 3 to the x dx. Now, this is our inner function rule, right? This 3x, because it is a power, right? So that will be our u. The derivative of that is 3 dx. And to solve for dx, we just divide by 3 and plug in. So now we're given the integral of e to the u du over 3. Now technically this is 1 du over 3, so that's considered a constant, not the du part, just the 1/3 part. So you could take it out. And it becomes 1/3 times e to the u du. All right, so from here, we know that the derivative of e to the x is e to the x, so e to the u would be e to the u. So 1/3 e to the u plus c, because this is indefinite. And we're not done. What are we missing? Our u. So we know our u is 3x. So then this becomes 1/3 e to the 3x plus c. Nice. And so let's do another one. Let's do a trigonometric one. And so let's do the integral of secant squared 5x dx. And so you should start to notice something when it comes to the integral of the secant squared if you're familiar with your trig stuff. So yeah, let's choose our u. In this case, it will be 5x. It is in the parentheses. Our du will be the derivative of 5x, which is 5, dx. And then we will solve for that dx, which then becomes du over 5. We then replace our stuff. We just substitute. It becomes secant squared u du over 5. Great. And again, with the constant stuff, this is just the same as 1/5 du, right? So let's put that outside the integrand. Becomes the integral of secant squared u du times 1/5. And if you caught on, the integral of secant squared is tangent. So now we are given 1/5 tangent squared u du plus c. Don't forget that. And then, yeah, from here, what do? Are we done? No. We need to place our u, which is 5x. So our final answer is 1/5 tangent squared 5x du plus c. And I am wrong. Remove that du. Sorry. Now it's just 1/5 tangent squared 5x plus c. Let's do one more. Our last problem will be the integral of 1 over 2x plus 1 dx. And so let's choose our u. We can make this entire denominator a u, and that is 2x plus 1. Pretend there was parentheses. And then our derivative, which is 2 dx. We then solve for dx by dividing both sides by 2. Seeing that this cancels out, we find that our dx is du over 2. So then we substitute 1 over u, and then our dx is du over 2. Now these don't really cancel out, but they form a constant, which is 1/2. So we can put that outside of our little integrand. And we are left with 1 over u du. So yeah, now that we have that, we know our integral rules, right? The integral of 1 over u is ln, is it parentheses x? No, it's absolute value x. Don't forget that. Plus c. And since that's not an x, it's a u, we'll put in u. Now, if we want to put it into x, which I tried to earlier, what do? You plug in our u, which is 2x plus 1. So let me see. We replace that with 1/2 ln absolute value of 2x plus 1 plus c. And that is our final answer. So thank you guys for watching. Until next time.